Stasi, and today we're going to talk with you about maintaining an open source cryptographic library and what kind of hell is this. Our previous speaker, Roman, was telling a lot about maintaining Victorian metrics, right? And I felt him. Like every slide he told, like the people don't use, we expect them to use, people ask thousands of questions. Oh yeah, I know the drill. Today I will explain you how it works in cryptographic world and what we do to maintain the library basically. So my name is Stasi. You can find me on Twitter by my nickname Vixentail. And I'm a security software engineer. I work at cosaks, which is security software company, and we deal a lot with cryptography. We have a lot of open source and free-to-use software, again, cryptography related. All our software basically solves the one and only issue, data protection, right? Different flavors, different approaches to solve the one and only problem, data protection. Searchable encryption, typical encryption, zero-knowledge proofs, yada, yada, yada. All these things just, again, to protect the data. We have cryptographers, we have software engineers, we have security engineers, and all of them are working on our software, and often other companies use our software, especially if they run like in critical infrastructure or fintech or AI, ML. They often need to protect some kind of data, so they often need to use some kind of tools, so they often use our tools, or they ask us to build custom solutions exactly for their use cases. So in crypto we trust. But of course, as you know, cryptography is complicated, right? And it would be really good if there was a way to make cryptography easy, to make cryptography approachable. And today I will go and explain how we actually do it. First of all, have you seen the updates of OWASP top 10? Can you please raise your hand if you did? Awesome. So for those of you who didn't, just in case, you know, OWASP, this is an organization, like a community-driven organization that cares about security, right? And every couple of years, like 4 years in this example, they update their top 10. Top 10 of popular mistakes, top 10 of risks that developers, like security risks, that developers do in their software. And OWASP just announced new top 10 2021, and you see there are some changes in categories, and what is important for me here to push you with ideas is number 2, cryptographic frameworks. Which means that often our software, like software we create, it doesn't use correct ciphers, it doesn't encrypt all data it should encrypt, or even sometimes people use base 64 as encryption. Yeah, 2021, right? So yeah, let's talk about Temis. Temis is an open source cryptographic library. It's 7 years old, so when Roman was saying that Victorian metrics is like 3 or 4 years old, oh yeah, I feel him, we have similar problems here. The idea behind Temis is that this is like a boring crypto library. I will explain what is boring crypto a little bit later. And Temis works across multiple platforms. Right now we calculate like 14 languages and platforms. It's a little bit complicated to calculate because, you know, like JavaScript as a language, right, Node.js as a platform, and WebAssembly, like Node.js and WebAssembly, they both can use JavaScript, but these are two different platforms, two very different ecosystems. So we roughly calculate as 14 languages and platforms. And OWASP is quite popular as for cryptographic library, okay. As for cryptographic library, and it even was recommended by OWASP to use, especially on mobile devices, when you need to encrypt some data, when you need to build end-to-end encrypted applications. So, yeah, as I mentioned, often Temis is used in mobile applications, web applications, AI, machine learning, fintech, yada yada yada. And there is a community of people who create libraries that encrypt some data, so they use them as dependencies. So we basically live in dependency hell. As some of the examples, maybe you have this application on your devices installed. Where, for example, this is like a note-taking app which has end-to-end encryption of user nodes. When we did this 2 years ago, Bear was running on 6 million devices. I don't know how many devices, how many users they have right now, but really a lot. Another example is very popular, I can't name, but very popular AI/ML application. You might probably also have it on your phones, but I can name it. And we use that there to protect ML models, right? Because this application generates ML models for the users, and we use them as a tool to protect those models against leakage, against tampering, against compactors. So the difference between Themis and other cryptographic libraries is that Themis is focused on use cases. We believe that the developers should not know how to use cryptography, because cryptography is complicated. We believe that developers should be able to solve use cases. As a developer, I want to store my data securely, I want to send my data securely, I want to make sure that the data is secure. You know what I mean. And that's why Themis has all these crypto systems that are focused on use cases. For example, if you're familiar with another very popular cryptographic library, Lipsodium, raise your hands who have tried Lipsodium. Awesome. So in Lipsodium, you probably know Sealbox, right? Interface, which is basically an encrypted container. You put some data in Sealbox, you seal the box, and data stays encrypted. In Themis, we use the same idea, and Themis and Lipsodium are more or less the same years old. So secure cell is an encrypted container. Do you want to store data securely? Okay, you put it in secure cell, it stays secure. Secure message is a way to send data to someone, from Alice to Bob. Right, you put data in secure message, you send it. Secure session, well, the idea is pretty obvious. I won't talk a lot about cryptography here, just to give you an example. From maintainer perspective, from library designer perspective, Themis looks like a cake because it has this modular layered structure. Obviously, we didn't implement our own cryptography. We use OpenSSL, Boring SSL, LibreSSL, whatever SSL. As a source of cryptographic primitives, we also had some time. We had even libraries that worked with Ukrainian cipher standards, but let's not go there. And then layer by layer, from cryptographic primitives, from OpenSSL, if you ever used OpenSSL, you know how complicated it is to use. We build abstractions layers that ends up with language hoppers, because as a Python developer, I want to have my APIs really easy to use. Right, as Go developer, I want my APIs really easy to use, and so on, so on, so on. And then now, this was a small introduction, just of the landscape. So basically what we have, a huge library, cryptography, 14 platforms, popular, more or less, as a cryptographic library, and it should work. It just works. So Themis supports several operating systems. But of course you know that operating system is not only its name, right? They have versions, they have bits, right? And to be able for users to be able to install library on their favorite operating system, we need to build a package for this system. And of course, if we go deeper, we don't forget about mobile systems. We have really a lot of them, right? So as a user, I should be able to install Themis on a system I like. Otherwise, I will go and say, I don't like this library. And now I have a question for you. How do you think for cryptographic library? Well, for any library. What is the most important thing? This library to be easy to use? I mean, as a developer, I can install it and start using it easily, right? Or this library should be hard to misuse. What do you think? Okay, who votes for easy to use? Is it more important for the library to be easy to use? Okay, like 1/4 of the audience. Who votes for hard to misuse? Wow. Okay. So I see that you prefer to have some troubles during integration, but not to have issues during maintaining, right? It was a tricky question, because I believe that the library should have both. Because what means easy to use? Take a look on this. This is, I copy-pasted it from the README from one very, very popular open source library, cryptographic library. Can you guess the library?
OpenSSL.
Say it again.
OpenSSL.
OpenSSL, right. Obviously, no one will use your library if they won't be able to install it. And many people, when they see the README like this, they like, oh no, go and I will select another library. And this is what easy to use means. So when we're talking about TEDIS and about all this operating system it supports, it means that we as maintainers should create packages and push packages to all the popular package managers on these operating systems, right? And now let's talk about languages. Because again, as a Python developer, I want just to be able to do pip install. As Node.js developer, I want to be able to do npm install. As mobile developer, as iOS developer, I don't want to know about anything. I just want to, enter one line in my configuration file and hope it works.
And you'll work for OpenSSL as well. Because OpenSSL is maintained by distribution maintainers, usually.
Yeah.
But not the last version.
One day also tennis will be maintained by distribution maintainers.
Yes, absolutely. I'm just saying that often when we are using library, as a users, as developers, sometimes we don't understand and we don't appreciate how much efforts maintainers put to make this library available on our favorite operating system, on our favorite language. Because this doesn't happen magically. We have scripts to be able to publish package and submit it to each of these package managers. And each of them is a hell. They have their own ideas of what is good and what is wrong. They have their own rules. They have their own support of firmware, of the versioning, right? And I will give you an example, right? Because previously I was doing a lot of mobile application development, so iOS as ecosystem, like all this Apple ecosystem, is really familiar for me. So to give you an example, in iOS world, we have two languages: Objective-C, old and boring, Swift, new and shiny. Then we have iOS, we have iPhones and iPads and MacBooks, and every year Apple does the same thing again and again. They update iPhone, they update Swift version. Many Swift versions are not compatible. Well, right now it's easier. They are more or less compatible. For each Swift version, Apple updates Xcode, the software you need to use, right? And they also update like iOS, and of course, community has some package managers. So in iOS development world, developers use 3 package managers: Cocoa Pods, CatPage, and Swift package managers. 3 popular package managers. So every year we have the same loop again and again. iOS update, Swift update, Xcode update, new devices, a new CatPage update, yada 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 yada. And you know what Apple did 2 years ago? They introduced Apple Silicon. Completely new CPU architecture, well, not completely new, but still. And you know what it means? That OpenSSL, as OpenSSL, they needed to push some changes to build OpenSSL for Apple Silicon. Then we have our own fork of OpenSSL, obviously. We need to build packages for Cartage, CocoaPod, and Swift Package Manager of this OpenSSL and make sure it works on iOS and macOS. Then we need to push it to Tennis, to build packages of Tennis, and make sure that this result, our cherry Tennis library, works on the Apple Silicon. And of course, this cycle, it takes time. And some effort. And of course, it leads to these in our GitHub. Oh, sorry, this doesn't work with this version of this when I use this and my laptop is this. I think iOS is the most popular label in our GitHub issue tracker because it's always like something is not working correctly on iOS. Yeah. Joy. And again, this is only one of 14 systems. I don't say that any system is as fragile as iOS, but still, every operating system, every community, every programming language, they have their own rules, they have their own process. It's not about the language itself, it's not about the syntax of the language, it's more about the process, how developers are used to do things. This is how developers do things in Apple world. So it was my first point about easy to use. To make library easy to use, sometimes it's complicated. Let's talk about hard to misuse, because most of you voted for hard to misuse. So, what it means for cryptographic library to be hard to misuse. Let me show you two quotes. First is by Daniel Bernstein. Okay. Please raise your hand if you know who is Daniel Bernstein. Awesome. So this is a very famous guy, cryptographer. Okay? So he told once that boring cryptography is a very good idea. Boring cryptography means that cryptographic software just works. It's very boring. Boring means good. Okay? So developers should be bored when they use this cryptographic library because they don't need to handle all these parameters, they don't need to update this library, they don't need to do anything, it's very boring. Boring crypto means good crypto, means easy to use, hard to misuse cryptography. Second quote is by Bruce Schneier. Do you know who is Bruce Schneier? Okay, another security guy. Okay? So Bruce Schneier told us that we should not give user options. Because if we give users options, they misuse our software. We should give only one button, do your best. And these two principles, boring cryptography and don't give user options, is the idea how to make your library hard to misuse for developers. For example, looks nice, right? This is iOS encryption, AES encryption cipher. This is AES encryption in Common Crypto library. Common Crypto was one of the fundamental libraries in Apple world. Luckily, right now, Apple has pushed a new library, CryptoKit, which is 2 years old. But this is what developers needed to do every time they wanted just to encrypt data. Yeah, nice function with how many? 12 parameters. And as a developer, you should be able to define which cipher you want to use, which cipher mode you want to use, what is your key, what is your key length, what is your init vector, what is your init vector length, what is your output buffer, what is your output buffer length. Yada, not boring. Too many mistakes. Fortunately, in the idea of boring crypto is not a new idea, so many libraries try to decrease the load and try to make the APIs easier. And this is one of the examples. This is another very popular library in iOS world. And I just copy-pasted it from their README. Can you find IIS encryption. Just encryption, you know, very simple operation. Can you find mistakes? We are looking for cryptographic mistakes here. Ideas? Say it again.
I cannot see what is the mode of operation.
What is the mode of operation? Yeah, we don't see it here. I will tell you, it's CBC. Okay, now you tell me, IIS CBC, good or bad?
It is just not obvious.
Yeah, that's not obvious, but IIS CBC, good or bad? Bad, okay.
Depending on use case.
Let's not go there. Let's just say bad. Yeah, but yeah, of course it depends on this case. Other mistakes, other things. Imagine this is the README of the library. So as a developer who does, yes?
Our key is limited to 3 characters because they are repeated.
Absolutely, yeah, you're correct. Using this key in example means that many developers will just continue using these keys. And this library is very, very popular, and I just don't know how many mobile applications still use this key as a key. And of course, this is a very bad key from cryptographic perspective. It's low entropy key. Another thing, IV, which is init vector, which is in IIS ciphers, should be random and long for every encryption. If you're not cryptographer, how you will know this? This library is very easy to misuse, although it looks like easy, right, 2 lines. Just to give you an example how we solve similar things in Tempest, basically it's the same idea, like 3 lines of code when you encrypt the data, but with a handy function to generate symmetric key for you, because you want your encryption to have long and nice, like strong entropy keys. Then no parameters, no IV, no padding. Because as developers, not cryptographers, you don't know what those things mean. Right? Everything, like all good choices, are being inside the library, are being hidden from you as developers, because you're developers, because you don't know what cryptographic ciphers to use. We even went further and we introduced a so-called passphrases API. When, as a user, you input your password, like passphrase, and Tempest then uses KDF, key directing function, to create strong cryptographic key from this passphrase and then uses this key to encrypt the data. Right? So we try to eliminate mistakes because obviously developers are not cryptographers, they don't know where mistakes are. And of course it looks similar for all the 14 platforms with a similar API, this is very important, with a similar order of parameters. Because as we found out that if one language, let's say Tempest on Ruby, if it uses another order of parameters in functions, developers won't read the docs and will just blindly copy paste, you know. So we made sure that API looks the same across all the platforms. So if you try using Tempest for one platform, you basically have all important knowledge you need to use it to another platform, which makes Tempest so popular for building end-to-end encrypted applications. Because mostly you have several platforms and you want just one library to rule them all. Okay. Let's forget about cryptography. Let's talk about software engineering. Roman before me, he showed you numbers about how many tests they have. I have very similar screenshots. I will also show you numbers with lines of code. So here you can see that Tempest core has 35,000 lines of code. Not a huge library. 35,000, well, okay-ish. Can you guess how many lines of code our tests folder has? 200,000, close enough.
10 times more.
10 times more. Who are you? Have you read the sources of Tempest? Yes, 10 times more. So 341,000 lines of code, basically 10 times more. Because, yeah.
How many of these are copy-paste?
Oh course, a lot of them are copy-paste. Obviously. I will tell you, because when you have 14 platforms, you copy-paste a lot of things, you know. You automate and you create templates, you create your own DSL, your own language, because you don't want to code on 14 different languages.
So, are these generated from templates?
I would say yes, but of course no. Unfortunately, we're not so smart to template everything. No, most of them were written by humans. We use I will show you an example. We use templates a lot when we do integration tests, meaning tests across platforms. You know, when we make sure that Python TMS can encrypt data and then Ruby TMS can decrypt data. As we have 14 platforms, writing all these metrics would take some time, yeah.
So does this mean we can divide this number by 14?
You can divide it by anything, but this is a good illustration, okay? Don't ruin my example, please. 10 times more. To give you, again, software engineering, to give you an illustration, what kind of tests are those? Obviously, we have cryptography tests, like NIST tests, to make sure that random is random enough. You know what that is. Random number generator, problem, entropy, yada, yada, yada. So we have NIST tests to make sure that random is random enough. Then we use a lot of fuzzing. We are big fans of fuzzing. You know what fuzzing is. Raise your hand if you know what is fuzzing, if you ever use that. Okay. For those who don't know, fuzzing is like automated testing, where basically you use random, you use fuzzing as a tool, and it will try to randomize inputs in your functions. So instead of writing manual tests, when you test all the inputs, you know, like empty string, null, integer max, integer mean, instead of writing all these manual tests, use fuzzing tool, and it tries to randomize inputs and find edge cases in your software where it crashes. Awesome. It found really nice corner cases. We use fuzzing a lot, especially for the core. And then we use a lot of static code analyzers, memory sanitizers, yada yada yada, just to make sure that we don't have obvious mistakes. As we previously mentioned, we use a lot of integration tests and backward compatibility tests. Backward compatibility means that our users that use TMS version something on language something should be able to decrypt data. It's very important in cryptography. Not encryption is important, decryption is important. Right? So that our users that use TMS of newer version of their language can decrypt data of TMS from previous version of another language. Okay, so backward compatibility and integration tests. And we found so many issues because of these tests. I really like them. Fortunately, TMS is stable for many years already, so I'm pretty calm. And we have a lot of tests, we use a lot of CI tools. We mostly use GitHub Actions right now on GitHub to test everything. We use Circle CI for nightly builds. We use Bitrise for iOS, Android, and macOS because, you know, Apple is a different world. And to do all this integration tests, to do all this backward compatibility tests, yada yada, we have our own CI servers that use BuildBot. Because we try to calculate how much money it will cost to run all these integration tests between 14 platforms and 10 operating systems and different TMS versions, and that's a lot of money. So instead of using cloud CI/CD, we use our own BuildBot on our own hardware, and we pay for that. Yeah, open source they say. Free, okay. I explained a lot about testing in this series of blog posts, so if you're curious what tools you can use in your library to make sure, like to automate security testing, make a picture of the slide, because then on the link there is a series of 4 blog posts about tools we use. Yes, I'll wait. Okay? Done? Ready to go?
Yes.
No worries, I will share the slides. So, and of course, previously I talked about just tests. but as a cryptography library, we should also do all the kind of security tests. So we do all the kind of security tests, cryptography tests, and we use like we use our cryptographers who are not developing tenets to review any cryptographic changes, and we often use external cryptographers and external engineers. And we found some issues thanks to the community, thanks to external, people who are just curious to find things. And now, at the end of my talk, I would like to illustrate a lot of things that Roman was talking about. Community and documentation and all the things. So before I continue, how often do you read readmes of the libraries you use?
Each time I go to the library and write a new.
Each time?
I want to read entire documentation messages reissues that I not misuse.
Each time this person uses libraries, they read readme.
No.
Wow, you have you have too much free time. Most developers just.
I love reading documentation because documentation is important to the.
Okay, let's do it. If you have free time, feel free to read our document, it's great. If you notice something, just let me know, okay? If you like to read docs, I will be happy. So in tennis, we also thought that developers will read readme. So we wrote a lot of readmes, a lot of documentation for every language we support. For all these crypto systems, for all these, cryptography details. We even wrote examples of cryptographic attacks. We wrote examples of key management, right? As a user, how you should manage keys, what is good, what is bad. But many users say, we don't want to read. Just give me the code. I don't want to read the docs. I want code. We said, okay, no worries. We will make you code pieces. And we put into our docs these safe to copy-paste code pieces. Code examples like code snippets that are okay to blindly copy-paste and put in your software without any hard-coded key things. And we thought, now users will be happy. You know what users responded?
Too far?
But how to use these pieces in our application, right? Okay, I'm copy-pasting it, but what to do next? We were, right, so, okay, we are very user-oriented, we understand things, and as maintainers, we want to make community happy. So our step number 3 was to create example application. And to give you an example, 1 million lines of code of example applications, comparing to 35,000 lines of code of the library, right? 10 times more of tests, and how many? 3 times more of examples. That's a lot of additional lines of code. And we thought, okay, we created this example application. It's really, a small and simple demo application that show how to use our library. You know what community replied?
Too much lines.
It's not
Too many lines.
understandable.
But I'm building my own application. Yes, you have your example, but I'm building some unique application. How I understand what from your example to use in my application. Because cryptography is complicated, apparently, right? And we thought, okay, we can handle it. And our step number 4 was to create a lot of use case specific applications, tutorials, like real application, free and open source, end-to-end encrypted chats, okay. Some secret storage things, secret storage like applications, okay. Like real applications for real use cases. support them, add these lines of code to our lines of code. And you know what community told us? Yeah, we want more. They told us that, okay, your applications are working, but my applications that I build don't work. So yeah, we were like, okay people, okay, cryptography is complicated, we are good maintainers, so we will make another step. And we created so-called codeless simulators, right? So we now have our own servers that has daemons, and they have a UI, like web interface, web application, where you as developer can copy-paste your encrypted data and make sure that somebody else's computer can decrypt this data, right? Just to make sure that you have configured everything correctly. Or in this example, for example, I am doing a mobile application that communicates on the backend and uses this secure session encrypted channel, and I use Tennis Simulator as Bob. You know, my application is Alice, and it's sending data to Bob. And if somebody else's computer can decrypt my application, my data, it means that my application is configured correctly. Because cryptography is apparently complicated, and apparently one computer is not enough to make sure that it works. Right, so we created these codeless simulators, and fortunately we stopped here. And of course people continue complaining, you know, like in Ukrainian, люди бідкаються. Whatever you do, люди бідкаються. But these were our last step in this journey. So obviously one readme is not enough. Yeah, I'm dropping out. Obviously, one readme is not enough. Yes, language-specific readme, cool. Yes, ready to copy-paste code snippets, awesome. Example applications, great. Real applications and tutorial, perfect. Simulators, cool. So yeah, just to give you an illustration, 4 years ago on this stage, 4 years ago, on this stage, CTO of cosaks, Eugene, was doing another talk related to open source and community. And this was one of his slides. Yeah. No, community is great, especially when you're a maintainer of a complicated open source cryptographic library. Community is awesome. So yeah, my key points. And of course, for listening to cryptographic talk, you deserve a kitten, right? So the key points. If someone will tell you, hey, please, can you maintain the cryptographic library, say no. Because that's a hell. There's a lot of things to handle. And of course, luckily, we have a team, right? So obviously, I'm maintaining Tennis for 4 years already, but we have a team. We have DevOps engineers, security engineers, cryptographers. You know, we have people who write Python, we have people who write Go. Without team, maintaining a library is overcomplicated. From another perspective, as security company, why we do that, why we maintain Tennis? Because, as I mentioned previously, it makes data security easy to use and hard to misuse for developers that don't know cryptography, and that's fine. We use Tennis a lot in our own software, we rely on it, so we make sure it's correct. We make sure that we don't have any backdoors there. And Roma, previous speaker, he told a lot about statistics and analytics, right? As cryptographic library, we don't have any analytics from our library, for obvious reasons. We don't want people, you know, to think that we steal their data. So yeah, it works. It works. Supporting library when you can improve your work if you use this library. And just to finalize my talk, I just want to tell you that we are hiring. Right now we have a lot of open positions, especially for SRE, site reliability engineers. And if you read this book, okay, raise your hands for read the book. Okay, I will remember your faces. So if you read this book, if you know what I mean, please apply. We have the position description on Dow, and this is like a QR code for Dow. Or if you don't want to apply, just want to hear how we work and things like that, ping me. My name is Anastasia, my nickname is Vixentail, and thank you for your